This is numbers 47 through 61 odd of section 3.1. For number 47, we are asked to find the domain of the function. If you recall, we have to start with all real numbers and then take away anything that would put a negative under a square root, anything that would put a 0 in the denominator of the fraction. Well, for this function, we don't have any fractions and we don't have any radicals, so our domain in this case is simply all real numbers, which you can write with the capital R with the extra vertical bar. That's the symbol for all real numbers. If we wanted to do interval notation, that would be from negative infinity to positive infinity. Next, we have the function L of u is equal to the square root of 3u squared plus 4. Because we have a radical, we want to make sure that there's no way to have a negative under the radical. In other words, we want what's under the radical, which is 3u squared plus 4, to be greater than or equal to 0. If I solve this, I can subtract the 4 from both sides, which leaves me with 3u squared is greater than or equal to negative 4, and then divide both sides by 3. So I'm left with u squared having to be greater than or equal to negative 4/3. I can stop here and sort of examine what I have. The point of this is to make sure that whatever number you replace u with, it's not going to put a negative under the square root. Well, we set that quantity under the square root greater than or equal to 0, solved, and we found that u squared has to be greater than or equal to negative 4/3. If you think about it, no matter what number I plug in for u, whether it's a positive number or a negative number or 0, whenever I square any number, I'm going to get either 0 or a positive number. Either of those would be greater than or equal to negative 4/3. So that means that the domain of this particular function is also all real numbers, or negative infinity to positive infinity. In other words, I can plug any number that I want in for u, and it will give me a positive value underneath that radical. For number 51, I would start with all real numbers. I have to take away anything that would put a 0 in the denominator of a fraction, anything that would put a negative under a radical. All I have here is a fraction with the potential for a 0 in the denominator. So I take that denominator, which is 4 minus z. Oops, that didn't look good. Let's try that again. We have our 4 minus z, and I'm going to set that equal to 0. That will allow me to say what value of z would put that 0 in the denominator. I know then that's what I would need to throw out. I'll solve this by adding z to both sides, which gives me 4 equals z. This tells me that if I plug in a z, or if I plug in a 4 rather, for z back into my function, in other words, if I try to find h of 4, then I get 2 over 4 minus 4, which is 2 over 0. I cannot have that. So my domain is just going to be the set of all z such that z is not equal to 4. I cannot have z equaling 4. If I want to write my answer in both inequality and interval notation, let's just go interval notation for this one. Then we can have everything from negative infinity up through 4, and I'm going to unite that with everything from 4 to positive infinity. For this particular problem, I have a radical, so I have to make sure that what's under the radical is not negative. In other words, I have to take that t minus 4 and set it greater than or equal to 0. These are the values that t are allowed to be. I can add 4. My 4's cancel, and I'm left with t is greater than or equal to 4. That means that as long as t is a number that's greater than or equal to 4, it can be part of my domain. So I can say that the domain is equal to the set of all t such that t is greater than or equal to 4. In interval notation, my interval starts at positive 4 and goes to positive infinity. For this problem, again, I have a radical, so I want what's under the radical, the 7 plus 3w, to be greater than or equal to 0. I have to make sure that there's no chance of a negative number ending up under my radical. I would subtract my 7, which leaves me with 3w is greater than or equal to negative 7. Divide both sides by 3. My 3's cancel. I'm left with w is greater than or equal to negative 7/3. So w can be anything as long as it's greater than or equal to negative 7/3 rather. In that set builder notation, I would have that the domain is the set of all w, such that w is greater than or equal to negative 7/3. As an interval, that would start at negative 7/3 and go to positive infinity. In this particular case, I have to make sure that I don't put any values of u in that make the denominator equal to 0. So to find out what values that would be, I would take my denominator, which is u squared plus 4, and set it equal to 0. I could subtract the 4 from both sides, and I get u squared equals negative 4. We know from when we talked about complex numbers that if I take the square root of both sides, I would get that u is equal to plus or minus 2i. This is an imaginary number. Because I'm only interested in real numbers, remember functions are values that, or functions or relationships that can be plotted on that real number system. I can't have any I can't have any imaginary numbers. So the plus or minus 2i would have to be out. Another way to think about that is there's no real number that I could square and have it equal negative 4. That means there's no real number that's going to put a 0 in the denominator of this fraction. So I'm free to choose any real number to plug in for u. So my domain is all real numbers, or negative infinity to positive infinity. In this case, I have two different things that I have to consider. I have to make sure that there are no zeros in the denominator of the fraction. So I'll take that denominator, that x minus 1, and set it equal to 0. Solving by adding the 1 to both sides gives me x equals 1. This tells me that 1 cannot be in the domain. Okay, that value 1 cannot be in the domain. But I also need to consider the radical. I also have to look at what's under the radical, that x plus 4, and make sure that it stays greater than or equal to 0. I cannot have a negative under the radical. I would solve this by subtracting my 4 from both sides. Those cancel, and I have that x is greater than or equal to negative 4. So I know now that I have two different restrictions on my domain. X can be any number that's greater than or equal to 4, except for this positive 1. That 1 would put a 0 in the denominator, so I have to throw that out. So if I put all this together in set builder notation, I can say that my domain is the set of all x such that x is greater than or equal to negative 4, but then I also want to say that x cannot equal positive 1. If x was positive 1, there would be a 0 in the denominator of that fraction. Finally, I again have two different things happening here. I have values of the variable that are not only just under a radical, but also part of the denominator of a fraction. So I have to consider both different cases. I have to first of all make sure that there's no way that I can plug in a value for t to make the denominator equal to 0. To find out what value that would be, I'll set the denominator equal to 0 and solve. I'll add that square root of t to both sides. That leaves me with 3 equals the square root of t. If I square both sides, I'm left with 9 equals t. So I know that t cannot equal 9 because plugging a 9 in for t would mean I would have the square root of 9, which is 3, and 3 minus 3 is 0. So that would put a 0 in the denominator. I can't have that. The other thing I have to be careful of, though, is I have to make sure that what's under the radical is not negative. So I would have to take that t and set it greater than or equal to 0. There's nothing to solve here. I'm already done. So I know that my value of t, or the values of the domain, have to be greater than or equal to 0, except 9. I would have to throw 9 out. So my domain is just the set of all t such that t is greater than or equal to 0 and t is not equal to positive 9.